Consider a weighted voting system with 3 players. If no one has veto power and no one is a dummy, find the Bonshoff power distribution. So the key on this problem is that they're saying no one has veto power and no one is a dummy. So no one has veto power, no one's a dummy. So that means all three players have equal power, right? If no one has veto power and no one's a dummy, then they're all equal. So what's their power? 1/3, 1/3, 1/3. That's all that's required on this problem. There's no big analysis needed. They have to all be equal if all three of them have, if no one has veto power and no one's a dummy, then they're all three equal power. Now, there's 2 other versions of this question that I want to make you aware of. So one of the versions goes like this. It says if player 1, so this is version 2. Player 1 is a dictator. This is a second version of the question. So what if it says if player 1 is a dictator? How does the power go then? Well, if somebody's a dictator, then player 1's going to have 100% of the power. Or we should change it to 1.0 decimal. And player 2 and player 3 will both have 0. No power at all. Because if player 1's a dictator, then he has 1.0 decimal, or 100% of the power, and the other two have none if player 1's a dictator. Now there's one other version. There's a third version of the question. So let me show you that. So the third version of the question is that players 1 and 2 have veto power and player 3 is a dummy. So if players 1 and 2 have veto power and player 3 is a dummy, how is the Bonshoff power going to break down in that situation? Well, if player 1 and 2 have veto power and 3 is a dummy, 3 has none, and player 1 and 2 are veto, they're equal, so this is going to be 0.5 and 0.5. So player 1 and 2 both have half the power, and player 3 would have none. So there's the 3 versions which you might see on this question about Bonshoff